Hello and welcome. Today we're going to do something special. So let's take a look here. There's our app. Just have to wait a second. And we can draw here. You can notice that there are other instances of this app open just here. And in each of these windows, I can draw something. And it's going to be updated everywhere. So that means that I can draw together with other people. So without thinking too much about it for a moment, let's try to get there. We're going to start with an empty project, and there is a package that I prepared for you, so I'm gonna find it. There it is. And the first thing I want to do is just to grab all those things and drop them into my project. All right. So let's continue with just preparing our objects that we're going to draw with. So I'm going to drag and drop these grapes 3D object into my scene hierarchy, and maybe scale it so that it is more appropriate, just like so. Maybe as usual I'm just going to change the camera background into a solid color, like that. And now I'm going to create a material for this 3D object. Right click, create material. Let's just call it grapes material, and I'm going to drag and drop it onto the object. So now what I want to do is also to add the texture that I prepared here. It's just gonna look a little better like that. Okay, so of course I can change the color however I want. Okay, so that's where we are. And what I'm going to be using in this tutorial is additional property or component that I want to add onto this object, which we worked with before. That is a collider. So I'm just going to scroll down here in the hierarchy, add component. Let's just add a mesh collider to it, and in its properties I'm just gonna take the convex tab here. Okay, so now we have this 3D object. It looks good for now, and since I want to be using this a lot, I'm going to make a prefab out of this. So I'm just going to drag and drop this object back into the assets folder, and Unity asks me whether I want to create a prefab. Yes. So just now it's important not to confuse these things. Maybe I can rename it just like that. Okay, So there we have it. I'm just gonna delete this. If I now drag and drop the prefab, it sits nicely there. Everything is fine. Okay, so first thing we're going to do is we're going to maybe start adding new 3D objects based on mouse clicking. So, and in order to do that, we need to come up with some kind of script that that deals with all the logic behind it. So, right-click, create C# script. Let's just call it add things. And let's start. Okay, so what we need first is, of course, some kind of reference to the game object that we want to add. So game object thing, whatever, and it needs to be public so that we're able to easily assign an object into it from Unity Editor. And now we have to learn how to detect mouse clicks on an object. And this procedure is called Raycasting. So let's try to do that. So first of all, what I'm going to do is I'm just going to create this basic logic, so conditional statement saying that if I press the button, something is supposed to happen. So if input dot get mouse button down, so whenever the mouse button is actually pressed, and I want the left mouse button, which is index 0, so 0 is left, 1 is right, and 2 is middle. And so if I'm pressing the mouse, do something here. So of course I want to be able to check at all times whether my script is working. I'm going to use debug for that. Right. Okay. So if I save this, I'm just gonna prepare the whole situation here so that I can go back and forth between my script and the editor, add features and check whether they actually work. So I'm gonna create a new empty game object. That's how I like to do it, script holder. And I'm going to drop this script onto it. And there we go, we have this public variable which wants us to specify the game object that we want to be using here. I'm going to drop the prefab there. And let's see what happens so far. So nothing, but if I press, you can see here that the console is telling me that I am indeed clicking. Okay, so let's add some more action. Now, in order to find out whether the mouse is actually touching something in the 3D scene, we have to come up with some sort of translation from the 2D space of where the mouse cursor is living to the 3D space of where our 3D objects are sitting in a scene. And the way to do that is through casting rays. So let's do that. Let's just create a variable called ray, and I'm going to give it a name, my ray, let's say, and it's going to, it's a function of a camera, so I'm going to call camera.main, which is our main camera that we're currently using. And then I'm going to call its function screen point to ray. So Unity has an automatic, so has a feature or a comment that that does all this for us. So, and it requires a position, and that's a position of the mouse cursor at the moment. So what we want to do is to type in here input the dot mouse position. Okay, so we created some kind of ray, and maybe the best way to find out what it is even is to just drop it into the debug instead of this stupid trivial clicking commentary. Okay, let's save this and check how this works. So I'm going to press play. Okay, so as we can see here in the console, whenever I'm clicking somewhere, new ray is generated and the debug is giving me its properties. So now what we want to do is to use this ray to intersect it with this object and to find the point of intersection. But before we're doing this, maybe it's worth to explain what is actually going on here. I think the easiest way to explain it is if I go into the scene, and this is how our scene looks like currently. We have a camera with some kind of 3D object, and the camera is facing this object, so we can see it in the preview here. And if you zoom out massively, you see that there is this back clipping plane. And I think the best way to understand what these rays are, they're essentially lines from the camera origin to some point here. And well, you can very well imagine that if there is a line going straight from here, from the origin of the camera to somewhere in the middle of the screen, there's a pretty good chance that it's going to intersect with this object. So, and this is precisely what we want to find out with the next improvement to our script. So let's do this. In order to do that, we need to use physics and raycasting. So what I'm going to do is I'm going to create another conditional statement saying something like this: if physics dot raycast, and I'm going to drop my ray here. There we go. Then I'm going to know whether I actually hit something. So, right? So what this comment here is doing is it uses the ray that we specified here and throws it into the scene in order to find out whether it hits anything. So what I'm going to put here is, right? Okay, I'm going to save that. So, and this one gives us a Boolean value. So whenever this operation here is successful, it's going to be true, meaning that our statement is going to fire. Otherwise, it's not going to, right? Okay, let's save this and go back to our scene, run it. So I'm clicking somewhere, not much in the console, but the moment I hit the object, the console is reporting that I actually did hit something. That's great. So now what's missing is that we want to know where did we hit this thing, and based on that we want to add more objects to the scene. So let's quickly do that. Right. So this command has, there's more to it. We can add after a comma different thing, like we can specify the distance that we want to be raycasting with. We can have some info about what happens there, and many other options. What we're going to use is the second option here, no, the third one, which is going to provide the data about this raycasting event outcome, and is going to drop it into a variable of our choosing. So I'm going to prepare in advance right here an appropriate variable for this. So I'm going to specify that it's a variable of a type raycast hit. So it's a special dedicated variable to store complex information that is contained in a report of such event, and I'm going to call it, let's just say, hit data, right? And here I'm just going to make sure that whenever this command fires and is successful, it's going to drop all this information into my variable, just like that. Right, so now whenever this happens, my variable is going to be filled with data from this event, which is great, because what that means is, well, I can use this data for some further operations. So let's check what we can find out. Hit data dot. Okay, so we can find out many things about what we actually hit, including the point at which our ray intersected the object in the scene, you know, transform, whatever, distance. So there's a whole bunch of information that are available here, and I can simply, I don't know, let's just start with transform dot name, and let's see what this does. So I save this, go back into the editor, play it. Nothing. If I press here, it reports that I actually hit the grapes. Right? Perfect. So, oops. What I actually want, though, is whenever I hit the 3D object in the scene, I want to instantiate a new object at the point of intersection between my ray, or wherever I click the mouse, wherever I touch the object. And so, yeah, as simple as this. I'm just going to instantiate my thing, which I referenced before, and I want it to be at the position that is available in my hit data. So hit data dot point, and then let's just specify rotation. So quaternion dot identity. Okay, semicolon. This looks pretty clean. Save. And let's see if this already does what we want from it. So let's go back to Unity right there. Okay, not much, not much. Aha. So now we can actually kind of draw with these objects. It's a little bit frustrating because, of course, it's very quickly quite crowded. We cannot rotate, we cannot do anything, but our main functionality is actually there, so that's great. Let's stop this and maybe fix some little things. Instead of having this rotation all the time the same, what I want to do really is, to have a bit of variation, so that these objects, are going to be rotated every time they're created. They're going to be facing, just rotated in different ways. So so the whole structure doesn't appear so repetitive. So what I'm going to do is maybe create here a vector 3 called random rotation, and that's going to be a new vector 3 random dot range from 0 to 360, and that's for all the 3 axes of rotation, like that. Don't forget the semicolon here. So I have the random rotation, and what I want to do is to turn this into a quaternion. Well, rotations are stored as quaternions in Unity. It's just part of the game. If you want to know more about what they are, the information is obviously available online. Otherwise, let's just turn it into a quaternion by this comment, quaternion dot Euler and random rotation. Okay, that's perfect. So saving this, let's see if that works. Yep, that's just about perfect. Okay. Okay, and maybe one more thing would be to introduce some color variation. So maybe I'm just going to create here my variable, let's say of type color, my color, and every time I'm pressing here, I'm going to generate a new one. My color is a new color. Again, random range from 0 to 1f, and that's for all the 3 channels, so which is going to be perfectly colorful like that. Now what we want to do, well, in order to assign this color into this newly created object, we want to remember the object that we just created. So what we want to do is to store it under a variable. We're just going to call it game object. New thing is the result of this instantiation, right? So now what I can do is new thing get component, right? So I want to access the mesh renderer of this 3D object, and specifically its material, and even more specifically its color. So get component mesh renderer, like that, material dot color, and I'm going to assign my newly created color right there, right? So I'm going to save this, close here, and see how does that work. All right, great. So now each one has a new different color, and yeah, that's pretty great. So I think next thing we want to do is a little bit of navigation here. So let's stop, and maybe before we mess around with that, you know, since we sort of completed one little chapter, I would suggest to save what we have so far. So save as scenes, adding things seen. All right. All right. So next thing I want to do is I want to be able to somehow move within this scene, so observe it from different perspectives, and so that, you know, I'm able to somehow look at this object from different angles, and I'm not running into this situation like that. So in order to do that, I'm gonna create a little rig which is going to consist of an empty object which is going to define the center of our scene, and the camera attached to that object. It's going to be some kind of a selfie stick, or I don't know how else to call it. Let me explain what I mean by that. So let's take a look at our scene. This sits in the zero, in Cartesian zero of our scene. This camera, on the other hand, sits at -10 distance and y1 up. I'm just going to zero it so that it's perfectly central, like so. And what I want to do is to create an empty game object in the very center, and I'm going to call this object camera pivot, and I'm going to drag and drop our camera onto this. So this creates a hierarchical structure, and so camera pivot becomes a parent of main camera, and it changes nothing in our game besides, and this is important, let's just preview it here. Take a look here. The moment I'm going to rotate the pivot, the camera is going to rotate around it, right? The same thing, if I move it, the camera is going to move, but it's going to always have this fixed reference. So it's almost as if it sits on a stick that is attached here. And that's very convenient because whenever I want to change what I'm looking at, I can. and then my camera is kind of going to follow. And then I can also rotate things around. So in order to do that, I'm going to need some kind of script that deals with this logic for me. And this is what we're going to do right now. So camera pivot becomes the parent of our main camera. And with this little rig, we're ready to start coding. I'm going to save for now and create a new script called, let's say, camera movement. These names are absolutely arbitrary, of course, so you can call it whatever you want. I don't know why this glitch is there, that Visual Studio is not opening the newly created script. Whatever, doesn't matter. Okay, so what we want here in the script is obviously reference to the pivot that we created. So I'm going to create a public variable of a type transform, and I'm going to call it camera pivot. Right, and now perhaps the first thing I want to do is I want to be able to change my focus, so change the center of my scene. And I'm going to use very same technique that I used for adding object. I'm going to be raycasting, and I'm going to be finding out where did I hit the object, and simply I'm going to change the center of my scene to that point where I, somewhere on the object that I just hit with the mouse, right? So that's going to allow us to somehow navigate through the scene. Let's try this. So I have a reference to the transform of camera pivot, which stores its position. Now what I want to do is actually I want to copy all this. I'm just gonna take all of that, copy and paste into here, right? But I'm going to throw away stuff that is unnecessary. So, well, I don't want to instantiate anything, so let's trash this. I don't want to change any colors. I don't want to generate any colors. I don't want any vectors or anything like that. Let's just erase everything here. So I have this empty conditional statement here. I already have the structure, which gives me the raycast hit data. Now the only thing I want to change is which button is going to trigger all this, because, well, I don't want the same button to be adding things to the scene and also changing position of my camera pivot. So I'm going to do this. So this is going to be our middle button used for navigation. Okay, so what I'm going to do here is I'm just going to say camera pivot dot position is hit data dot point. All right, let's see what happens. Save, and let's go back here. Okay, I can add objects. Nope, nothing. Nothing. Okay. Obviously, I created a script, but I'm not even using it. So let's just drag and drop this script onto my script holder and take a look. Of course, we need a reference to the camera pivot. Let's just drag and drop it there. Okay. Well, that should fix it for now. Okay, we can click around, we can add objects. and we can change where we are. I can go there, I can go there, right? It's not very smooth, but it kind of does the job. So yeah, it's pretty great. Okay, let's make it a little bit more professional. And for that, we're going to learn about interpolation. So instead of this jumpy movement that we have right now, we're just going to smoothly interpolate between the current position and the new position of our camera pivot. Let's do that right now. Okay, so let's take a look into our script. So right now, obviously, this is a very hard transition. We simply are assigning a new point to our previous position. In order to create this smooth motion, which is just going to look more pleasant, and basically is a very useful technique for changing things smoothly. It can be, you know, colors or rotations or whatever else you want. We're going to learn how to use linear interpolation. So let's take a look here. I'm just going to start typing this comment here. Vector 3 Lerp. So Lerp stands for linear interpolation, and what it wants from us is vector from which we're starting, vector towards which we're going, and some kind of time variable. So this is, it's kind of explained here. So when this number is going to be at 0, we're going to be fully here. When this number reaches 1, we're going to be fully here. And between 0 and 1, we're going to be somewhere in between. Right? So with that, I'm just going to comment it out, not to be confused, and create some variables. So I'm going to say, I guess I'm going to need my previous position. Maybe previous position like this, and I'm going to need a vector 3 next position. All right, so this is where I start, this is where I want to go. And then maybe just to initialize those vectors, I'm going to say in the start that both previous position and the next position are simply camera pivot position. So next position okay, so I initiate them as identical, and then another thing that I need is this time variable. Let's just get back here, right? From where we're going towards where we're heading, and where are we on a time scale. So let's just call it a float position interpolation time, and it's going to be 0 at first. Okay, so what we want to do in the update function, so all the time that the game is running, is to linearly interpolate between our previous position and the next position. according to this number that we're going to change constantly. So I'm just going to say previous position to next position according to position interpolation time. Okay. And now, of course, we want to add something to this position interpolation time, namely a tiny fraction of a number, 0, let's say, something like this, very, very small. F, right? Okay. So, again, what's going on here? While the game is playing, we are interpolating between two vectors according to this number. And this number is increasing all the time. Well, that's not yet what we want. What we want is to make sure that our next position is defined every time we hit the object that we want to inherit this position from. So just like that. So now I'm assigning the hit point to the next position, and of course my position is constantly changing, so I actually also need to update the previous position to store where I was before. Previous position is camera pivot position, right? Because this is something that is going to be changing constantly. And I want to reset this timer. So every time I hit something and I update the position vectors, I'm going to start counting this time from 0. All right, here. It might seem a little confusing, but let's see if it works. I mean, I hope it does. So, all right, we can add objects, and not much, unfortunately. Not so great. Okay, let's try to fix this. All right, let's go here. Obviously, that was not very smart. I am interpolating, which is a very nice thing to do, but I'm not doing anything with this value here. So, of course, what I want to do is to change my camera pivot position with it. Just like that. Camera pivot position is vector-free interpolation. Okay, so save that. Go back to the game, and let's see if this works. Okay, adding stuff. All right, that's just about perfect. Check this out. I can actually move in the scene. Well, it's all good. It's really nice, but probably something that you might notice is, our user interface influences quite a bit the kind of structure that we're able to generate. You see, because we can only move around, we can generate this kind of stuff. We can only build in one direction, and the only way to go about it, if we want to have freedom to navigate in space and build in space, well, is to rotate around this object. Well, we're going to do this next. But before, maybe let's make our interpolation even more sophisticated with one easy step. So now what is going on here is a linear interpolation, and our variable is time that is being incremented here. So there's this little variable that stores a small number, and it just, it keeps on growing. But essentially what matters here is when it's 0, we're here, and then when it hits 1, we're here. And then if it increases further, it doesn't matter. What we can do, however, is to be more specific about this motion here. And so we can use so-called animation curves. Take a look at this. I'm going to introduce a variable here called public animation curve, and I'm just going to call it response curve, like that. What is this thing? Well, let's just find out. I'm gonna save, go back to the editor, and take a look at what showed up here, right? So in my variables, in my fields here, I have response curve now, and I can click on the empty field, and I can create different curves, right? So that would be your normal linear interpolation, but you can have different functions. I kind of like this one, so I'm just gonna keep this one. And then what we want to do in the script is, instead of adding these little increments to our time variable, we want to evaluate this curve and read this value. So we want to go along this axis and read this value, right? Which is going to be, in turn, used for our interpolation. Let's try to do that. So I'm going to save everything here, go back to our script, and now instead of this basic number here, what I'm going to do is I'm going to say what I want is response curve dot evaluate, using this number, right? So I'm still, going linearly here. I'm just adding some little fraction constantly, but since my curve has a particular shape, what I'm going to get here is a number between 0 and 1 that is not going to act linearly. Let's see, what does this mean specifically? I'm going to save the script and go into the editor. Okay, so I can add. You can see that at first it goes fast, and then when it slowly reaches or towards reaching the target, it kind of slows down, right? We could assign a completely different curve to it, like this one, for example, and see, right? It's a completely different feel. Or like this one, right? Or something completely crazy. Whatever, it's a mess. I have no idea what it's gonna do. Right? You get it. So let's go back here. I think that's pretty good. Okay, perfect. So now, time to introduce some rotations. Okay, so for the rotation, we're going to make something very simple. So I'm just going to add 2 buttons on the sides, and if we press one button, it's going to rotate left. If the other one, it's going to rotate right, and that's that. This should give us a rudimentary user interface, so that we can be a little bit more free in our drawing. Together with changing the position of the pivot of the center, I think it's going to do the job just fine. Okay, so let's do it. I'm going to, first of all, okay, this is all saved. I'm going to create a button, and maybe I'm just gonna make it big, and I'm gonna dock it to the one side. I'm gonna call it turn left button, and perhaps I'm gonna erase the text. I don't need that, but I'm going to use this user interface elements that I prepared for you. These are PNG files, so let's prepare them first. Clicking on this, and I'm just going to change it into a sprite, apply that, and the other one as well, like so. And now I can just use it as UI elements, like that. So this is going to turn left, and now the other one, maybe I'm just gonna copy, paste, and dock it to the other side, and change its name to turn right button, and also change the arrow. Okay, so that's just fine. Now we need to assign some action to these arrows, to these buttons. So we need to modify our script. Let's save the scene and get back to coding. So I think we can use very similar logic to the one that we used for manipulating the position of the camera pivot. This time around, we want to essentially take the pivot and rotate it by some angle. You know, let's say maybe each time we press, we're going to rotate it by 90 degrees. Right? And we want to do it with code, and we want to do it smoothly, right? Just like with changing the position. So instead of going step by step, I'm just going to go straight into the smooth interpolation. So let's check the script. So following the same logic, we're going to probably need a previous rotation, next rotation, and some sort of interpolation value. Okay, but this time, instead of vectors, we're going to be working with quaternions, because this is how rotations are stored in Unity. So I'm going to go here and create some variables. Quaternion previous rotation, quaternion next rotation, and float rotation interpolation time 0, just to be precise. Okay, so down here, what we want to do is, since we're going to trigger this change not by mouse, so the rotation is not going to respond to mouse hitting any object, it's actually going to be its own function that is going to be called by a button interacting with this script. So what I'm going to do is I'm going to create here public function called turn left, right? And it's going to have similar logic than, you know, what happens here, but instead it's going to be about rotations. So, oh, maybe let's just initialize these two variables first in the start as previous rotation is camera pivot dot rotation, and for now next rotation as well. Right, so they're both the same at start, but the moment we press the button, which is going to interact with the script, we want to do something similar to this. Do we? Let me think of this. Okay, so what we want to do is previous rotation is right where we are right now. Next rotation is we just want to add 90 degrees, right? So probably I'm just gonna create a quaternion from Euler, so from Euler angles, and we're going to rotate about wait, 0. Let's see, I just want to experiment with this. 90, 0. Let's keep it as a fixed number first, right? So next rotation, and here in the update, what we want to do is we want to smoothly interpolate between next rotation and previous rotation. So let's go here. Camera pivot dot rotation is quaternion this time, Lerp, from previous rotation to next rotation. And I'm going to use the same curve, the same response curve. Of course, I can use another one, but I don't want to complicate it too much now. And instead, I'm going to use rotation interpolation time variable, like that. And of course, I want to make sure that this variable is being updated. So rotation interpolation time plus equals something very small. And I want to reset whenever I update, so that it goes back to 0. Rotate like this, 0. Okay. So let's see if I'm correct. This should, at least for the first rotation, do the job. Save this. And we need to assign this button to this action. So let's go to the left button, scroll down, and on-click reference the script holder and the camera movement script turn left function. Let's see if we're somewhere close. So we can add objects. Aha, that's perfect. Well, we can't do anything else. but at least we were able to rotate once. So let's now make it so that we can continuously rotate around. Okay. So instead of fixed number, what we want to do here is we want to probably the easiest would be to take pre-rotation dot Euler angles dot y plus 90. I believe that could work, right? Because we're, yeah, right, we have a quaternion here, and then we're reading its Euler angles, and we're rotating about y, so x, y, z. So that should do, if I'm not completely wrong. Let's go back to Unity here. I can do that. I can do, wow, cool. Okay. So now I can update the center, right? And then I can rotate around it. Okay, so let's do the same thing, but reverse. I'm gonna save this because I'm really proud of myself now. So let's go here. So what I want is, well, same thing, but reverse, right? So I'm just gonna copy this whole function and just call it turn right. And now instead of adding 90, I'm just gonna, you know, subtract 90. And let's see if we're good. Save this. And now, of course, I need to assign the turn right button to this new action. So referencing script holder here, camera movement, turn right. Okay, save this. Let's see if everything works. We can turn. So can you can see here what's going on, right? There's our camera. There's our camera pivot, right? We're rotating around. We can update our origin and rotate around that one. Which gives us quite some freedom, actually. But simultaneously, and I find it actually quite interesting, it limits the possibilities. So somehow it predefines the kind of drawing that we can make. So I think conceptually it could be quite useful if you're thinking about the relationship between what can be, essentially between your drawing and your tool, right? So there are certain constraints which are, let's just call it encapsulated in the interface. Okay, perfect. So we have this. I would say this is as good as it gets. What we are going to do right now is the whole network magic. So let's stop this for a moment, save everything, and focus on networks now. First thing we need is an account here. So in your case, you're going to need to sign in and then log in, and then you're going to be able to access the dashboard, which is what we want. Now, what is Photon? Photon has nothing to do with Unity. It's a cloud service which enables developers to create network applications of different kind, and probably that's enough for us at this point. What we want to do is to go to the dashboard, and in your case there's going to be nothing here most probably, and you want to create a new app. Here in Photon type we need to choose this one, Pun, and we just give it a name, let's say Ika experiment whatever, right? So I'm just gonna create this app, and there it is. The only thing we want from here is actually just this number. So I'm just gonna click here and copy it. This number matters because this is it's a code, it's a key that is going to allow your application to access the cloud service. And that's all we want from this web page for now. So we can go back to Unity right here. And the second thing we need is a plugin that is going to do all the network stuff for us behind the scenes. So in order to obtain it, we want to go to the asset store. And again, probably you need to create an account and log in and whatnot. And from there, you want to search for Photon, second one. Scroll down. So there are different versions of it. Some of them are pretty expensive, but what we want is the free version. So it's there for purposes like this, to check how it works. And okay, so we can open this in Unity. And what's going to happen is Unity is going to open its package manager and asks you whether you want to import that. So yes, that's what we want. So let's wait. Okay, there we are. We want to import all that. And that's going to take a little while. And the first thing you're going to see is the setup wizard. We can close the package manager if we want. So what this does is it helps us setting up the whole project, and it requires the number that we just copied from the web page. So this is your app ID, and since I have it in my clipboard, I'm just going to paste it and set up the project. Okay, so for now, let's just not touch anything here. We can go back into our scene or into our game view. What matters is that we have Photon loaded, and whenever we want to change something, we can go into where was it? It must be somewhere here. Photon Unity Networking, and then we can launch the wizard again. We can change application ID or whatever else. So, okay, we have that. Now, what we want is, I guess, we're just going to create a new scene here, which is going to be our login scene. So that's our drawing so far. Let's just create a new scene and make it kind of look consistent. like that. What I want from this scene is actually to have only one big button in the middle, which is going to be our login button. So I'm just going to create one and put it in the middle, delete the text, which I don't need, and maybe replace its standard sprite by this portal person here. So I'm just gonna change it into a sprite and then go to the button, drag and drop that. That looks great. And then maybe change its name to login button. Perfect. So now what's left, I'm just going to save the scene as a login scene because there's nothing else that I want from it here. What I need is a script that handles all the network stuff. So that's going to be a little tough, but let's go through it. Create script, network manager, right. Let's open it. Okay, and inside here, we're not going to use any of that. So we can easily delete that. What we want to declare in the beginning is that we're going to be using Photon dot pun. So we're going to be using some code that is available in this library. And let's go. So what I want is, so my button needs to interact with something here, and so it's going to need a public function to interact with, and this public function is going to start a series of events that are going to first access the server and then join a common room for a game. So I'm going to show you how to do it step by step. So first, I'm going to create a public void connect me, just like that. It's an arbitrary name, right? I just made it up. And here, I'm just going to say Photon network connect to master. Or no, connect using settings. Okay. Like that. So there's the whole description. What matters for now, in order to ensure that all the instances of the game, so whether you run it on different devices or on one device, but they're just like different windows, that they all have the same version, because this is going to ensure that they're able to talk to each other. So what we want to do is Photon network settings app version, app settings, app version, like that is, and I'm just gonna type in here something. What matters is that it's consistent. Okay, so I'm just trust me, it's necessary. Okay, so now this whole thing essentially immediately when you call this command, it goes into the cloud through the internet, right? And it accesses its services using whatever particular settings. So it's a special situation because of course network communication means that it can fail if you don't have internet, or many things can go funny. So what we're going to be using now is a set of so-called callbacks. So that means that we're going to ask Photon server for something, and then we're going to wait for its response, right? And in order to do that, and then the moment it responds, it tells us something back. We're going to react to this further, and it's going to be a sequence of steps like this. So in order to be able to do this, what we want to do is add here mono behavior pun callbacks, like that. Well, actually, it seems to be not very happy with it, so I'm just gonna delete that. We're going to be relying on the mono behavior pun callbacks from now on. And what this allows us to do is to create and use so-called callbacks. So essentially, Unity is going to wait for Photon server to respond back to us, and it's going to register its response and capture it using the special functions here. They're initiated like this: private override void override void on, damn it. Okay, sorry, not private. Okay, override void on connected to master. So that's going to be our first response from the server. And we're going, in order to get a grip on what's going on here, we're going to be using debug log to tell us what's going on. So, right? So essentially what's happening here is we're creating a public function which is going to be triggered by a button, and it's going to ask the servers whether we can connect, and it's going to try to do that. And if we are able to do that, it's going to trigger this automatically, the callback function. Okay, let's see if this works. So I'm saving this. I'm going to my scene here, and I'm going to make, as usual, an empty script holder, which is going to host my network manager, like that. Okay. And now what I want is that the login button is interacting with this script holder and its network manager, and it's calling the connect me function. I'm going to save this and check whether this works. So press, okay, not much. If I press here, I should observe in the console. Aha! So you can see that it took a little while, but it is indeed connected. So we're actually online now. That's great. So let's use that. So next thing we want to do is the structure of Photon service is such that it consists, so there is a general server, and then hierarchically there is a lobby which hosts rooms, and this is where your players can meet. So we're going to first join lobby, Photon network, join lobby. And I think we don't need to put anything here. And again, we're going to wait until Photon tells us that we actually managed to join a lobby. So public, whoops, override void on joined lobby, right? And I'm going to make sure that everything is fine by debugging and saying, okay, joined lobby, whatever that means. Okay, save. And then if this is successful, then I'm going to say Photon network join or create room. So this is where our players are going to meet and do things together. So this room needs a name. I'm going to call it Ika room whatever. And then it needs some additional stuff. So room options, so there are, of course, many different options how you can set these things up. I'm not going to go into the details of it. I'm just going to use the most basic standard stuff. So new room options, and then type lobby. Let's just fill that in. I think I don't remember how this thing is called. Let me check in the documentation. So I'm gonna save here, pause for a second. Okay, so Photon real-time typed lobby dot default. Right, so that's a little convoluted, of course. But this, I mean, you really don't have to be concerned with that. Anyhow, so now that's the last step here in the series of calls and responses. So now what we want is override void on joined room. And here you can just say debug.log joined, and then I'm just going to check whether we are in the right place. So I'm going to ask Photon network about current room. Count of rooms, current room. There we go. Name. All right. That should do. What is that? Can I do this? No, that's wrong. What's the problem with here? Wait, that looks weird. Okay. There we go. Okay, save this and let's see if this whole sequence makes sense and does what it's supposed to be doing. Because if it does, then we're all set. So save this and let's try it. So I'm going to play. And now I can press here and I should get this series of debug messages. Perfect. I joined the ICA room, which I just created. That's perfect. Now, what matters is that we're saying here join or create room, which means that if you happen to be the first person on this application ID to create a room with this name, well, so if it doesn't exist yet, you're going to create it. But if there is something like this existing already, you're just going to join it. And this ensures that you're all together in one network place. Okay, so last thing that I want from here is to simply change the scene to my drawing scene, because all the network stuff is done, right? So I'm just going to scroll up here and say that I'm using Unity engine.network. Nope. Scene management. So I just want to change to the drawing scene. And I'm going to make sure, let me just type it here. So network, nope. Why am I so fixated on networks? Scene management or scene manager dot load scene, and I'm just going to use the index because our whole application consists of two scenes: the login scene, which I'm going to give an index 0, and the drawing scene, which is going to have the index 1. Okay, so this should do. I'm going to save this, go back here. And now, in order for the scene management to work, I want to go into the build settings and make sure that I add open scenes. So you can see that the login scene has an index 0, and then I'm going to go into the other scene, which is the drawing one, right? And then add this one under the index 1. Okay, that's perfect. So if all that is correct, and it should be, we're actually ready to go. I mean, we need to start modifying the drawing scene now, but let's just check it for one last time. Okay, we're here, we're pressing this, let's see the console, connected, joined lobby. Okay, we're in the room and we're in the other scene. That's perfect. That's what we want. So now the time to update the way we're drawing here. So what we want to update here is actually our script which adds things. So let's take a look at it. There we go. We have this instantiation situation here, right? And that's what we actually want to change. So instead of normal Unity instantiation, we want to use Photon instantiation. So instead of locally creating new objects, we want to create objects over the network. I'm going to show you how to do this step by step, and it involves, on the one hand, operations here in the script, but also updating our prefab. So let's just go back and forth and make sure that everything is fine. I'm going to be using photon.pun. Okay, and now let's just comment this thing out for a second, and instead call Photon for the network, actually, sorry, dot instantiate. Okay. Now, there's slight difference to Unity's original instantiate, because we need, instead of a reference to a game object, we actually want a name of this object here, right? So I'm just going to make sure that, let me just go out from here. Save this, go out, and check what's the name of my prefab. It's here. So it's called grapes pre. I'm going to go here and instantiate grapes pre. And then the rest is just the same. So I'm just gonna type in my position, hit data point, and then my rotation. So copied from the way we were doing this before. All right, and that's that. So on the code side, that's it. I'm going to save this and now make sure that it works. So here, in order for Photon to actually be able to use this prefab, we need to drag and drop it into the resources folder. So under Photon real-time, nope, Photon Unity networking, there is a resources folder right here. And whatever you want to instantiate over the network, it needs to sit in that folder. So I'm just gonna drag and drop this into the resources folder. All right, that's fine. Let's just double check. They're here. So that's first. And the second thing is, if you want to instantiate something over the network and perhaps do something to it as well later on, it needs to have something on it which is called Photon view. Okay. So there we are. It just adds this little component, and let's just not touch it at all at this point. All the stuff that we need for this particular example is just taken care for us automatically. Okay. So I'm going to save this scene. Okay. So if we're here, then that means that we should be able to run our script now. Let's try. Okay. We can rotate. Nope. Of course, so now we cannot do this, and the console tells us that you cannot instantiate anything before you even join the room. And obviously we did not do this because I just tried to launch the scene from here. I need to go through the whole procedure in order to be able to use the network. So let's start from the login scene. Okay. Oh, we're gonna have to fix the lighting. Okay. So it seems that we're able to instantiate these objects on the network. There you go. Perfect. Okay, but before we start working on the details of this, I think it's important to check whether it works at all. So the way we're going to do this is we're simply going to build a version of this application and make it, just like a standalone piece of software, and run both from here, from the editor, and then the standalone version. So I'm going to go to the build settings, and here I can choose how I want to build it. I don't want a development build. Do I need anything from... Oh yeah, okay, I'm gonna go to the player settings and just make sure that resolution is windowed. So I'm just gonna make it like that. Adjust it to your taste. Essentially, if it's not windowed, it's gonna automatically go into the full screen, and then it's just gonna be a hassle to work with it. I think this needs to be our number. Okay, so we have that. I can close this here, and yeah, just build and run. So I need to find a place for it somewhere. Let's just say I'm just gonna be on my desktop, new folder, Eka builds, whatever. Oop, I have one already. Whatever. I'm just gonna build it here. It's gonna take a while, so I'm gonna pause. Okay, so we have it. And now let's see if it works. So I'm going to play this one and go through the whole login process, and then also launch this one and go through the whole login process. Okay, and it does not work, it seems. Is there any messages here? No, this doesn't matter. So I assume there's one more place where we need to make sure that our versions are matching. Let's just take care of this. So I'm going to go into Window, Photon Unit Networking, Server Settings. Okay, our development region is all fine. Cloud, okay, app version is 001, so that's perfectly fine. This is all good. Okay, so let's just make sure that we have everything in place. So first of all, our Photon setup, Photon Unity Networking wizard, locate server settings. So we need to have app ID number here. So this is something that you're copying from the web page. That's very important. Then you need to have the correct app version here, right? And then in order for us to find the same lobby and room, we're going to fix the region here. So I just typed in EU, and that's that on the Photon side. Then in our script, our network manager needs to have the sequence of calls and responses, and we need to really make sure that our app version is the correct one. So we're initializing a variable here called mySettings, which is Photon's app settings, and then we're just making sure that we assign this number to the app version. So having all that should make everything work correctly. If I go now to the build settings, I make sure my structure is there, everything is fine. I can build, and I'm just going to go into here, whatever, override what I had there before. So what I'm getting is my application here. I'm just going to open 2 instances of it and figure out whether they work. So I'm going to enter here and enter here. Okay, so let's take a look here. Aha, it's being updated. So now we can draw with someone else. The thing that we're going to fix next is that we can distinguish who is drawing what. And in order to do that, we're just going to assign different colors to the objects created by different players. So, and that's going to be our last improvement. So, last part of this tutorial is going to be about adding special properties to the objects instantiated over the network. So what we want to achieve is that, let's take a look at our script. Add things right here. Okay, so we're instantiating our prefab over the network, and we're providing its position and its rotation. That's all fine. However, we have to be aware that the moment we're instantiating this, it just exists over the network. So we simply cannot do the same thing as we did here. So, somehow remember the object and update I don't know, its properties, like its color, because this way we would only do it locally. What we need to do is to be able to do it for all the objects in over the network. And what we're going to use right now is another property that we can insert right here after comma. So you can see that there are 2 optional parameters. One of them is a group. We don't care about that. I'm just going to type in 0 here. But another one is instantiation data. So essentially, we can provide additional data in a form of an array of objects, which can be decoded over the network and influence how these instantiated objects are. So I'm just gonna type in here my data. Right now, of course, it means nothing. So I'm going to create an object here, my data. And wait, what's wrong here? Right, oh, and it needs to be an array. That's important. Okay. And we want to instantiate it, of course. So new object, and we don't want to transfer that much. We just need to need some space for the color. So my data index 0. So it's again, we're creating an array, but it's an array which consists of only one object. I know it's kind of weird, but this field expects an array, and in this case we just don't have that much data to pass through it, so we're just creating an array with one variable in it, and it has an index 0. So here we just want to put our color data. Now the thing is that Photon can only instantiate relatively basic or common data types. So we're going to need to transform what is a color right now into a vector. I mean, it's essentially the same. It's just 1, 2, 3 channels, so they could just as well be 3 dimensions, just like in a vector. So no problem here at all. Okay, but what we want is that this color is not assigned to every single newly created object, but it's constant for every player. So instead of creating this color every time we're clicking, we're just going to create it once and then pass it to all the objects created by this player. So I'm just going to take this away from here and put it in start. And now, just for the sake of compatibility with Photon network, I'm just going to change this from color to vector, vector 3, and here as well, vector 3, just like so. My color. Okay, so now our instantiate command carries with it our custom data package. Okay, that's perfect. So what's left to do is to receive this data on the other side, that is on the side of the newly created object. So I'm going to save this and go back here into the editor. So let's go into the adding things scene. There is my prefab here. What we want is that each of these prefabs additionally has a little script on it which is going to be called every time this object is instantiated, so it shows up in the scene, and is going to receive the data that we're sending while creating, and is going to do something with this data. So we just need to decode it. Okay, so I'm just gonna find our prefab in the resources folder, take a look at it, open prefab, and add a component. Let's just call it on instantiation as a new script. Okay. Yeah, as usual, let's just make sure that we can open it. So, of course, we have to be able to use Photon pun, and the only thing we need here, we actually don't need any of that. And what we want is pun magic callbacks. There we go. ipun instantiate magic callback. This one sounds funny. Actually, we don't need this, I guess. Or no. Actually, let's take a look. There is an error. It says does not and implement interface member. Show potential fixes. Well, okay. If that could be a fix, let's do that. Okay, so essentially what we're getting is a kind of callback. So a function that is called whenever the object is instantiated on Photon instantiate. And then there is some info that this command makes available. So what we want to do is we want to use this information. So I'm going to say vector 3, because this is what I'm expecting. My color, let's say my data is info dot, what do we have here? Sensor over time to do different things. Okay, Photon view dot instantiation data. Perfect. And since this instantiation data is an array, we want to specify that we want just index 0 of this array. Okay. Now, again, an error cannot implicitly convert from object to vector. Yes, but we can cast. So vector 3, which means that we know what to expect, right? It's a generic object type, whatever, but we know that what's under here is actually a vector. So what we're doing by this parenthesis here is we're forcing Unity to treat whatever comes out from here as a vector, and then we're assigning it to our local variable. Okay, so if that's the case, then we're simply ready to use it for the object that this script is sitting on, which is going to be each of our prefabs. So I'm going to say this dot get component of a type mesh renderer, and I want material color, and I want it to be a new color which is made out of my data, right? My data.x, my data.y, my data.z. Okay, so that's that. I'm going to save this, and the only thing I need now is to make sure that the script sits on our prefab. So I'm just going to take a look. There is a mesh collider, Photon view, and there is the uninstantiation script. Perfect. So if we have it, then everything should be just fine. Let's see if that works. First, without building. So I'm just gonna go into scenes, login scene, and start the game. Okay, everything seems to be working. and I'm in the room. Okay, and I'm adding objects and they're all the same color. So it seems that everything is fine. Let's see if this works over the network. I'm going to go to build settings and build this into a standalone application. Let's say here. Okay, let's see. So one, another one. I'm going to enter here, and I'm going to enter here. Okay. All right, it's a different color. So if I open another one, it seems that there's some information missing. This, however, seems to be adding just fine. Okay, so there are some reliability problems, but this we're gonna have to fix some other time. But in general, everything seems to be working. So I would say that's going to be it for today. And see you next time.